Okay, we have an arithmetic sequence and we have to prove that the difference between the squares of any two terms is a multiple of 24. Okay, difficult question, don't worry about it. I can't see where it's going to go yet, it doesn't matter. You don't need to be able to see exactly how you're going to get all the way to the answer with some questions. The important thing is to pick up the pen and just start, okay? One thing we definitely can do, we've got an arithmetic sequence, we can definitely work out the formula for the nth term. So let's do that, okay? So, n, what is 1, 2, 3, 4, 5, okay? And the common difference is 6 every time, or plus 6. 6. Okay, so you write down the common difference, which is 6, then write down n after it, 6 times the common difference. Now, when n is 1, 6 times n is 6, but we want 7, so we have to add 1. And that's it. We've now got the formula for the nth term. And pick one of these. Let's pick n equals 5. 6 times 5 is 30, plus 1 is 31. Yes, it works. Good. Okay, so we've got the formula for the nth term. Where do we go from here? Well, prove that the difference between the squares of, any two terms. Okay. So, it's asking us to think about any two terms in the sequence. Could be this one and that one, say, okay? Or it could be this one and the 1000th term. It doesn't matter. The point is, it's asking us for two different terms. So, we need to introduce a different letter here. N refers to any term in the sequence, okay? So it could be this one. But we need a second letter to refer to the other term, this one. So let's call that, or let's use the letter n, okay? So the nth term, this one say, its value would be 6n plus 1. The other term, any two terms, the mth term, its value will be 6m plus 1, okay? 6m plus 1. Are you with me? So you need to be able to introduce this by yourself as well. So just go over that again. Our two terms, our any two terms, their values are given by 6n plus 1 and 6m plus 1. N and m are both integers and they refer to, that's n or m if you like, okay? And they refer to the position of the two terms. Okay. So, m is bigger than n as well. So the minimum difference between n and m is 1. So if that's n, then m must be, so if n is 2, m must be 3 or bigger. Okay, right, now, prove that the difference between the squares of any two terms, the difference between the squares of any two terms. Okay, let's build that next. We've got our two terms, the difference between the squares of any two terms, okay, so if we square both of those, the difference, and subtract, that will give us the difference, okay? So I'm just going to go through it all at once. The expression we're looking for is, remember, 6m plus 1, that's bigger because m is bigger than n. So that's the bigger one. So we need to subtract the smaller one from the bigger one. So the squares, that means 6m plus 1 squared. The difference between the squares, difference means subtract the square of the other one, 6n plus 1. Okay? Great. We've got our expression for the difference between the squares of any two terms. So already we've got quite a few marks in this question. Even if we don't get full marks, that's a good achievement. Okay, So now we have to prove that that is a multiple of 24. Okay, again, it doesn't matter if you can't see where it's going to go. You don't need to be able to know precisely how to get the answer. Just keep going and see where it goes. We can definitely expand these brackets and see what this looks like, right? So let's do that. Okay, so that is equal to, have to write out the brackets in full. So that's 6m plus 1 times 6m plus 1 minus 6n plus 1 times 6n plus 1. Okay, right, that equals 6m times 6m is 36m squared. 6m times 1 is 6m. 1 times 6m is 6m. 1 times 1 is 1 plus 1. Okay? Minus, now I'm going to introduce big square brackets here because that minus is multiplying this whole lot. Don't try and do too much at once. We have to multiply out these two brackets first and then it's minus 1 times the whole lot. Okay? So 6n times 6n is 36n squared. 6n times 1 is plus 6n. 1 times 6n is 6n. 1 times 1 is 1. Okay? Equals, combined terms, 36m squared. 6m plus 6m is 12m plus 1. Right. I think we're good enough to be able to combine terms and multiply by minus 1 at the same time. So let's do it. Minus 1 times 36n squared is minus 36n squared. 6n plus 6n is plus 12n times minus 1 is minus 12n. Plus 1 times minus 1 is minus 1. Okay? Equals 36m squared plus 12m. Plus 1 minus 1, cancel. Okay? Minus 36n squared minus 12n. Okay. Where do we go from here? There's a common factor of 36 there. So let's pull that out. That's 36 times m squared minus n squared. There's a common factor of 12 there. So let's pull that out. Plus 12 into m minus n. Okay? Good. Again, we've probably picked up 1 or 2 more marks just from going from there to there. Good. Okay. Look at this. Does that ring a bell? M squared minus n squared. It's a difference of 2 squares, isn't it? Let's expand that and see where we go. So that's 36 times m minus n times m plus n. Okay? That thing is equal to that. Difference of 2 squares. That's the same, plus 12 into m minus n. Okay? Look at that. We've got a common factor now of m minus n. We've also got a common factor of 12. So let's pull out 12 m minus n. We're going to factorise, and that's our common factor, okay? So 12 m minus n goes into 36 m minus n 3 times. But it's also multiplied by m plus n. So it's 3m plus n. Okay? And 12m minus n goes into 12m minus n once. Okay? Good. I think that's as far as we can go. Or at least we can work with this and prove that that's a multiple of 24. So let's take a pause and see where we are. We have our we have our expression for the difference between the squares of any two terms, and we've shown that that is that. Okay, and apparently this is a multiple of 24. So if we can argue and prove that this is a multiple of 24, full marks. Okay, so why would this be a multiple of 24? Well, it's 12 times something. If that something is a multiple of 2, then, or if we can prove that that something, that bit there, is a multiple of 2, then because it's multiplied by 12, 12 times multiple of 2 is a multiple of 24. So, our problem is reduced to showing that that is a multiple of 2. Right. In situations like this, where you have two variables, in this case m and n, consider the case where m and n are both even, m and n are both odd, and one's even and one's odd. Okay? And then you've covered all cases. And it should turn out that in all those cases, this will be a multiple of 2. Okay, so let's start with m and n both even. Okay, m and n even. Right, this bit here. When m and n are both even, m minus n, okay, if m is even and n is even, and m is always at least 1 bigger than n, so if they're both even, n minus m must be a minimum of 2 if m is 6, say, and n is 4. Okay, if you subtract two even numbers, you get an even number. And we also know that m is at least 2 bigger than n. So therefore, that must be a multiple of 2. Okay? Good. Right, this term here. It's 3m plus n plus 1. Okay? Right. m and n are both even. You add two even numbers together, you get an even number. If you multiply an even number by 3, which is an odd number, you get an odd number. So that's always... No, you multiply an even number by an even or an odd number, you get an even number. Sorry about that mistake. Okay, that's always even, that bit. When you add 1 to an even number, it's always odd. Okay? Good. So, therefore, the whole thing, m minus n multiplied by 3 m plus n plus 1, so that's this whole thing here, okay, not including the 12. You've got a multiple of 2, okay, that bit, m minus n, multiplied by something that's always odd. So that will also therefore be a multiple of 2. Okay, because when you take a multiple of 2 and you multiply it by something that's odd, you're still going to get a multiple of 2. Okay? So, good. We've shown that for m and n is even, that is a multiple, that we've shown that the difference between the squares of any two terms is a multiple of 24. We've achieved that for m and n even. Okay? Because we've shown that is a multiple of 2, and therefore 12 times the multiple of 2 is always a multiple of 24, and that shows that that's a multiple of 24. Okay, good. Right. Let's consider the case where m and n are both odd. Okay? Right, same thing again. The m minus n bit. Okay, that, if you subtract an odd number from an odd number, let's say 9 minus 5 is 4. You always get an even number. And not only that, it would be a multiple of 2 because there's at least a difference of 1 between n and m. M is always at least 1 bigger than m, but because they're both odd, the difference must be at least 2. So that's going to be a multiple of 2. Okay, good start. Right, the other bit. 3m plus n plus 1. Okay, when m and n are both odd. Sorry, it's a bit sloppy. Right, m plus n. If you add two odd numbers together, you always get an even number. So that's even. Multiply an even number by 3, you still have an even number. You add 1 to an even number, so that's always even. Add 1 to it, it's always odd. Okay? Same situation, same conclusion. Therefore, m minus n times 3m plus n plus 1. Just to go over it again, we've got a multiple of 2 multiplied by something that's always odd. That's always going to be a multiple of 2. Brilliant. We've proven that that is a multiple of 24 for mn both even and mn both odd. It's looking good. Okay, again, just go over it. That thing is always a multiple of 2, so 12 times a multiple of 2 is always a multiple of 24. Excellent, right. What about m even, n odd? Okay? m minus n. Right. m is even and n is odd. Subtract an odd number from an even number, you get an odd number. Okay? What about 3m plus n plus 1? Okay. m is even, n is odd. That's an even number plus an odd number. That bit is always odd. 3 times an odd number is an odd number. An odd number plus 1 is an even number. Okay? Therefore, what about an odd number times an even number? Therefore, m minus n multiplied by 3 m plus n plus 1. Okay. Right, we have an odd number multiplied by an even number. Well, an odd number times an even number is always odd. For example, even number 4, odd number. It's always even, isn't it? Of course it is. Even number 4 times an odd number 7, for example. 4 times 7 is 28 even. Okay, so that's always even. But is it always a multiple of 2? It will be. But how can we prove that? Well, we know that m minus n m is even, n is odd. That can be as low as 1. Okay, that can be as low as 1 because m is even this time and n is odd. So m could be 7 and n 6, for example. In other words, they could be adjacent terms, or m5 and n4. M is even, m4 and m3, okay? M even, n odd, 4 and 3, they can be adjacent, and that can be as low as 1, okay? It's odd and minimum value is 1, right? So, if we can show that the minimum value of this is 2 or greater, we've won. We know that this bit is always even, but what's its minimum value? Well, it's all positives, it's looking good, isn't it? So m is even and n is odd. The smallest value m can be is 2. The smallest value n can be is 1. So the smallest value that can be is 3. 3 times 3 is 9 plus 1 is 10. That has a minimum value, even, and a minimum value of 10. So we've got something which is minimum value of 1 times 10, minimum value of 10. The minimum value of the whole thing is 10. So therefore, if something is even and it has a minimum value of 10, then it's definitely a multiple of 2. So therefore, multiple of 2. Okay, so it's a long question, but we're nearly there. So we've proven that this is a multiple of 24 for mn even, mn odd, m even, n odd. There's only one left to do, and that's m odd, n even. Okay. Same thing as before. M minus n. Right. M is odd and n is even. An odd number minus an even number is definitely going to be an odd number. Okay. But what about its minimum value? M has to be bigger than n. So odd number minus an even number. Hang on, did I get it right here? An even number minus n is bigger than that. Even minus an odd. Yeah, okay, it's fine. Yep, it's fine. Odd minus even. Yeah, same thing. M odd could be 5, n could be 4. So again, same thing. Minimum value is 1. Okay, that's fine. Right, and 3 m plus n plus 1. Okay. Right, m is odd, n even. An odd plus an even is always an odd. 3 times an odd, so that whole thing is always odd, plus 1 is always even. Okay, minimum value, excuse me, minimum value, smallest, all positives. Now the smallest number that m can be if m is odd is 3. It can't be 1 because then n would be 0, which doesn't exist. So m3, m odd, n even, it's 3 and 2. So the smallest that can be is 5. Okay? 3 times 5 is 15 plus 1 is 16. So it has a minimum value of 16. Okay? I'll just check that again. M plus n. M is odd. M is odd. Yeah, it can't be that. It has to be that. N even. Yeah, it's 3 and 2. 50, yeah, that's correct. Okay. Right, nearly there. bear with me, m minus n times 3m plus n plus 1. Okay, so this whole thing here, we have an odd number times an even number. So I'm not going to make the same mistake I made before. An odd times an even, such as 3 times 8 is 24. It's always even. Okay? Good. Now its minimum value, minimum of that is 1, minimum of that is 16, so its minimum value is 16. If something's even and its minimum value is 16, it's definitely a multiple of 2. Therefore, multiple of 2. Ah, and we've done it. Full marks. What a marathon. 6 marks. Okay. I hope that makes sense. Okay, I'll just quickly go over it from the top. Okay. They gave you an arithmetic sequence. The first thing to do, obviously, is to work out the expression for the nth term. Okay? You can do that without thinking, right? And get at least 1 mark. Right. When these sort of questions say any 2 terms, okay, just immediately introduce the same expression, the formula for the nth term, but just use a different letter. I chose M, you can choose anything, okay? And then you've got your expressions for your any 2 terms, right? Good. Next bit, you need to look at what the sentence is and do the converting a sentence into maths skill. So, difference between the squares of any 2 terms. It's just that. The squares, so you square them, the difference means subtract. And this one is bigger, so you have to subtract the smaller one from the bigger one. Okay, then you have to show that that's a multiple of 24. Again, even if you can't finish the question, you can definitely multiply out these brackets and do this and get to about here maybe. And then, the more these questions you do, the more practice you get, you can see how to factorize and where to take it. And that's how we ended up with this expression here. We used the difference of 2 squares and we kept factorizing. We pulled out a factor of, I pulled out a factor of 12 times n minus n at once. You can pull out a factor of 12 first and then the n minus n, doesn't matter. So you end up with your expression for what they want, the difference between the squares of any 2 terms. And then comes the arguing, okay? It takes a lot of time. But remember, just follow the algorithm. Just start off by considering the case where m and n are both even, right? It's like a recipe, just follow it. Then put m, n odd, put 1 even, 1 odd, and then the other one odd and the other even. And you've covered all cases, okay? And then just argue about the individual terms. You see the way I did it here. If you've got a multiple of 2 multiplied by something's always odd, you always have a multiple of 2, for example. And that's it. So yeah, there you go. I'll leave it there. I hope that helps.